Hi, my name's John Moorman. I'm a data architect over at OneCall here in town. And I'm here to present today about Azure SQL and some of the various storage options that you get with Azure SQL. So I've been at OneCall for about 1.5 years now. And when I was called in, they were looking at consolidating a bunch of existing systems and creating a brand new system completely based in Azure. So we've had a bunch of pitfalls along the way, and I don't want to say pitfalls, but we've had a lot of opportunities to overcome different things. And so hopefully I'm going to share some of that with you to help you through those, and also to show some of the different storage options. So if you've seen my presentations at SQL Saturday, this is going to be different than that. And it's also going to be a little different because, one, I found out about this Tuesday, and yesterday I had 2 teeth pulled. So I just took some medicine, but I think I'm okay. So I haven't started stumbling yet. But someone did make the mistake of giving me one of these things. I'm going to try not to misuse it. But there is a whole bunch of things. And I do have some demos near the end. But if you have any questions at any point, please feel free just to call them out. The beginning part's I'm gonna probably go through pretty quick with the different storage options, and then I'll show you some of the really cool features of the Azure SQL database itself. So we're gonna look at the different storage options, and this includes everything from your Blob Storage to actually Azure SQL database, even Cosmos DB. We'll look at some of that. Also look at some of the data movement options. How do you get data from place to place when it's in the cloud? You know, everyone knows how to do that on-prem, but when you get to the cloud, things are different because you don't have hard drives. Security, big thing. And I know that holds a lot of people back from moving up to the cloud. It's amazing the amount of changes that have come. There are still opportunities, but it's constantly evolving. So we'll look at some of the different ways to secure things. And then, like I said, we'll do a deeper dive into Azure SQL database. For those of you who know me, I see a couple familiar faces here. I've been involved with SQL Server, well, from a developer side using SQL Server, well, a long time ago, and SQL Server admin architecting for the past 20 years. So Azure was a completely new animal to me when I started 1.5 years ago. I mean, I'd done a little bit of stuff on my own. I was working on a side project where we were using the Azure SQL database, but this is how we got deeply into it. This Polaris project at OneCall, and I tell you, I love it. It's changing constantly, so you do have to be comfortable with constant change. This is my 5th time I've given this presentation. Every single time I've given it, and it's only been over the last year, a little over a year. Every single time I've given it, something has been different. There's been something different on the Azure Portal. There's been some new feature and preview. And this week was no different, and I'll mention it when we get there. So the first thing is, how many people here are using Azure? Just basic show of hands. Okay, so good. We have some people that are using it and some people that are considering it. To start it, I just want to give some basic terms because you might hear me throw these things out. You might be like, what's that mean? So at a base level, we have subscriptions. So everything in your subscription is accessible to other objects within that subscription in some manner. At OneCall, our subscriptions follow kind of loosely our SDLC. So we have a sandbox, we have dev, QA, UAT, and production. So everything that's involved for that subscription, or everything that's needed for that subscription, is contained there. Resource groups are a way of logically breaking down those subscriptions. So you can clump your SQL servers together. You can clump your Azure Search together, your Service Fabric instances, you can VMs. You can, whatever you consider a logical grouping, you would probably handle that within a resource group. Pricing tiers. It used to be called something else, I forget what it was, but they finally renamed it to what it truly is, pricing. Because when you're in Azure, everything is from Microsoft, all right? So keep your wallet handy, because they're going to be reaching into it from time to time. For most different objects will have a basic pricing tier, standard pricing tier, and a premium pricing tier. And guess what? More and more for each one. So you also get different benefits at each level. And as we found out the hard way, on the standard pricing tier, you don't get memory tables. So I'd created a new table. I was like, oh, we're going to be pounding this one. So I'm like, oh, let's create this memory table. Compiled, tested locally, all's good. We went to deploy it to our sandbox environment. I'm like, what do you mean? Did I check in something wrong, something else? No, memory tables are not supported on our standard tier. So, but it was supported in the premium tier. And since I have Dev Edition on my desktop, hey, that's considered premium edition. Lovely. Okay, so we also found out other things. We found out which database developers didn't upgrade to SQL 2017 when it came out. We put in a stored proc that used a 2017 feature, and a couple people was working. A couple other people, myself included, was like, hey, how come this string ag function doesn't work here? It was just SQL 2017. Azure supported it immediately. SQL 2016 doesn't support it, or at least not in the version that I had. So be aware of that. So the pricing tiers can come back to bite you. Things like Azure Search, your basic tier gives you a whole bunch of stuff, but it's only 3 copies of your index. Okay, not a big deal. It could still handle, I forget how many tens of millions of records in it. So that wasn't a big deal. But when you move up to like the standard tier, all of a sudden you get 7 copies of the same data. So there are differences, and you'll see that differences in your performance. Again, on the Azure, looking at the Azure SQL side, when you move up to the premium pricing tier, you also get memory disks. So not just memory tables and memory indices, but they're guaranteed that the hardware supporting it is really efficient. So what are our different data storage options? Like I said, as you can tell, Azure SQL Database is near and dear to me, but there are so many other cool options that we now have available to us. File storage, everything from blobs and files to queues and tables. Azure SQL Database, Azure Search, Cosmos DB, Azure SQL Data Warehouse, Azure Data Lake, and SQL Managed Instance. So we're going to touch on all of these momentarily, starting with file storage. You think about, at your most basic level, you need files. You know, whether it's a CSV you're ingesting, XML, JSON documents, you're going to be ingesting files at some point in time. And the Azure file storage is durable, secure. Here's one of those changes. Literally, well, I guess now it's a little over a week ago, but as of July 31st, all of them are stored encrypted at rest. 2-3 months ago, only Blob Storage, and I forget which other one, was encrypted at rest. So now they all are. So that's good. And you get the normal things that you would expect with Azure too. So you have multiple copies of your data out there for you. So blobs are also, and there's also Storage Explorer. which is just a free tool Microsoft gives you. Kind of like File Explorer, but allows you to see your storage within Azure. So blobs is the most versatile in my opinion. They're HIPAA compliant, which is a key. One call, I don't know if I mentioned it, but we do workers' compensation, and we're also starting to go into group health. So while I don't have anything stored yet that requires HIPAA compliancy, I chose it based upon future need because I know we're going to need it. And it's much easier to build that security in from the base. Files. These are kind of network file shares. They can be shared between VMs, which is actually kind of cool when you think about it. Can't really do that on-prem. Well, maybe you can with a network file share, but they don't share the exact same data. And up here in Azure, they can. Disks, only thing that kind of sort of resembles a hard drive on your local. When you create a VM, you can also set up disks for those VM. And it's just your OS, your temp, as well as your virtual hard drives. All of those would be set up as disks within Azure. Queues. This is actually another pretty neat one. If you're a dedicated SQL Server person, one of the things about Azure is we no longer have Service Broker. So what can we do that's similar to Service Broker? And this is queues. So it still requires some application development, but it allows you to put stuff on a queue and know that it's going to get processed sequentially. And these things are big and hugely And the last one is tables. These are key value pairs, kind of like a JSON document. And in fact, that's where a lot of it starts from. They're not exactly deprecated, but they're losing some of their first-class citizenship because they're actually being pulled into two different things, either your Azure Data Lake or into your Cosmos DB. So Cosmos DB is based upon all different JSON documents. So it doesn't have a set schema, so whatever you throw in it kind of figures it out on its own, which is very similar to how the Azure Table Storage was working. And this one probably no one can see. So let me see if I can make it a little better. What this is showing is even within your storage system, you have different options that you can check. And you can see here, in here it's saying V2 storage, general purpose, performance, again, pricing tier. So which one costs me more? Secure transfer required. So do we need SFTP to get here? Do we need something credentialed in order to get here? Access tier. This is only showing cool and hot. There's actually a third access tier of archive. And one of the really wild things about Blob Storage, at least it's wild from my standpoint because I'm so painfully used to having to keep things for a certain amount of time and getting rid of them. You can actually configure at the file level how long to retain your stored files. So right now you can say anything less than a week old, I want to keep it hot. If it's up to a month old, I'll keep that in cool. After that, archive it. If I need it, I'll take the second or two hit it might take to get back. So there's all these different tiers to look at. And replication, your different options for storage. Again, there's always multiple copies, but you can actually keep multiple copies between geo-replicated zones. So if you're in US East and you typically have your failover in US West, you can actually set this up with the redundant storage. And that also goes with your Azure SQL database, which we'll look at in a little bit too. And then, like I said, there's data lake storage. So eventually, the way the Azure data lake looks, well, we'll get to that momentarily. Questions? All right. Azure SQL database, again, my favorite. It's your relational data store. And for anything that you need normalized, this is where you want to go. From an applications perspective, very similar to your on-prem databases, similar connection strings. You can also set it up with machine learning and analytics, and we've done that. And like I said, we're going to have a deeper dive on the Azure SQL databases in a little bit. Azure Search. Touched upon this earlier. This is really cool. It's, like I said, very similar to Elasticsearch. About the biggest difference between Azure Search and Elasticsearch is with Elasticsearch, when you throw your files in, it automatically figures out the data types. Azure Search, you have to state what your data types are in advance. So depending upon how you like it, I mean, to me, I've also seen instances where Elasticsearch, we put the first thing in and it had a number, but then somewhere down the line, there was a letter in it and it didn't like it. So I kind of like stating everything up front, but Elasticsearch has some other advantages that Azure Search doesn't have. You can't go wrong really with either one, so it's just a matter of what you're most comfortable with. Completely JSON-based, REST API, and you perform everything using simple regexes. We loaded up one of our Azure Search on the basic tier with 22.5 million records. We were throwing all kinds of regex expressions at it. Most of them, we didn't have anything that ever took more than a second, and most of it was under 500 milliseconds, most of it being in the 200 to 300 millisecond range. So extremely performant on your larger data sets. One of key, again, HIPAA compliant. But it also does some cool things with synonyms. So trying to think, if you had restaurant and eatery, or if you had plural versions of a term, it's smart enough to figure that out. I don't know how it does it, but it's pretty darn cool that it does. Autocomplete, I think it says it's coming soon. I believe it's currently in public preview, or if it's not public preview, it's private preview. This is kind of like your Google or Bing experience where you start typing and it starts answering for you. So that's coming soon for Azure Search. Okay, it helps if I hit the right button to go the right way. Okay, Cosmos DB. Cosmos DB is big. Previously, you might have heard it called Document DB. Microsoft is throwing a ton of money at this. I mean, a ton. And more than just Document DB, more than just Azure DB. Eventually, from what I've seen, and I can't find any documentation on this, but I could see it from some of the build conferences, they're talking about both Cosmos DB having relational parts and your more big data parts, all rolled within the same database. The Cosmos DB has and we're getting back to the other one. I'm waiting to see, because if we can keep parts of our database relational, and then parts of it have the Document DB extension, this is going to be a really, really powerful thing. Just learned, actually while prepping for this presentation, the whole Azure Portal is based upon Cosmos DB. All the information that's stored in the background, all your different parameters, all your different performance marks. They're all stored locally in Cosmos DB, or a geo region. 5 different consistency models for your Cosmos DB. Everything from gotta be there to, hey, it can become eventually consistent, right? So if you've ever ordered something from Amazon saying, wow, that's a great price, And then you get an email a couple hours later, sorry, it was sold out. Yeah, that's the eventual consistency model. So one of the cool things, indexing. What indexing? Everything is indexed. In fact, you have to go out of your way to tell it not to index something. If it's in there, it's indexed. And there is incredible latency guarantees. 99% of the time you're going to have reads in less than 10 milliseconds, writes in less than 15 milliseconds, if you believe the marketing. And Microsoft has never told us a fib about anything like that before, have they? There's also geofencing, which is pretty cool. Well, pretty cool if you're China. It's like, okay, I don't want anything outside of China. You can do that with your Cosmos DB. It's also got multi-homing. I'm like, huh? So if you go to hit part of your Cosmos DB, you know, it's in East US and it's down, it knows, well, where's the next copy of that data stored? Oh, look, we have one in South Central US. It automatically rehomes you to that other one, knowing that the data you're looking for is there. I'm like, wow. And this is, we aren't talking config file changes or anything like that. It knows. It's like, hey, this is pretty cool. So it also has a bunch of different attributes. So you can have your key value pair, column family, your document Mongo type DBs, or even graph databases. It has different capabilities for each of those systems within Cosmos DB. And so why isn't everyone going to Cosmos DB? Well, you don't want to put me out of business. No. You're still going to need database people, but it's really good if the shape of your data changes constantly. So if your documents are coming in and they're no two are alike, or you know, some are alike, some of them aren't, this might be a very good choice for you. So if you also have a really, really high throughput, literally millions of transactions per second, say, you know, your Google and your Google ads come up, that's real high throughput, you need that. Also, if you need lots of data, and we're not talking terabytes, we're talking exabytes to petabytes of data. This is where you need to go. So you know what it means, right? Get your wallet out. But Microsoft is throwing a lot of money at this, so I would not be surprised to see within the next couple of years they're promoting this more and more for us. And a lot of the information, and this kind of breaks into the next one, which is the Azure Data Lake. A lot of this information is stored as documents on a file system somewhere. So if you need to look at the document itself, you can literally drive down to the file system, drill down to the file system, and check it all out. I was wrong. I forgot about that Azure SQL Data Warehouse. This is something we keep looking at as something, wow, this would be cool. If you've ever worked with PDW, Parallel Data Warehouse, which is an on-prem solution, Steinmart was actually one of the case studies for Microsoft about 10 years ago. Super, super performant. I mean, all kinds of network drives, network capacity, memory drives, everything, and it's all. And they used to sell these PDW units. Haven't heard about them much in recent years, have we? The main reason is the Azure SQL Data Warehouse, and they could put all this stuff up in the cloud, and you can access it. Right now, the Azure SQL Data Warehouse has some limitations. I believe the current size limit is like 4 terabytes. So if you have a large, really large data warehouse, you'd have to shard it a little bit, and you'd have to know where to go to get the different information. But it does the same thing. There's all the built-in compression, the Vertipack. It has the column store indices, which have came in, I think, in 2014. I think it was readable in 2012, and then, however, it's all in there now. the memory tables. So all this information is now available in the cloud. So why do you need it on-prem? Here's the data lake analytics. The Azure Data Lake is just really storing your stuff. And I mean everything. So all the different flat files that I mentioned, if you're running any kind of logging, all you need to do is store it out there, and you can have jobs running in the background which will automatically push all that information together, pull it all out, and everything is based upon your file system. So very similar to Hadoop. One of the other things it also do, you have the map reduce functionality. One of the things it also has is Polybase, which is one of these kind of, I don't want to say hidden, but not a lot of people utilize it. But Polybase, you could speak to any database server natively from SQL Server. So I was talking to our Microsoft rep. He's like, yeah, if you ever want to have your Oracle database up here, you just send us external hard drive. We'll load it up in the cloud for you. And then you can access it from SQL Server using Polybase. Okay, my jaw would drop if my teeth hadn't fallen out yesterday. But it really is that amazing. So Azure Data Lake, it's Hadoop on steroids. So you get all this, you could throw other database servers up there. You have your access to Microsoft. The reason why we keep looking at Azure SQL Data Warehouse and saying, maybe we don't need it yet, is because we have our Azure SQL databases and we have our different flat files stored everywhere, and we have our different statistics that we want to monitor in different places. It's like, well, if we use Azure Data Lake Analytics, all we need to do is run those things in. We can start building some aggregation of them, and then we could just report right on top of it, kind of like we would do with Hadoop. It's crazy. It's really, really impressive. The last one is managed instance. You might have heard that this is, I think their internal name was Cloud Lifter. This is something I think that came out into public earlier this year. What this is it is a SQL server in the cloud, but it's just like your on-prem SQL server, except it's up in the cloud. You actually specified drives, your Azure drives. You would actually, you get SSIS, which you don't have in the cloud. You get SSRS, which we don't have in the cloud. So we can run jobs, which there's some workarounds for these things, and hopefully we'll get a chance to do that. But it's a way you could take your on-prem SQL database, throw it up on the cloud. Microsoft takes care of putting on all the patches and everything. They take care of all your backups for you. And it's like, okay, so why aren't I doing this? Yeah. So, and there is that pricing tier. So if you have an Azure SQL database as a PaaS solution, platform as a service, means you define the schema. You know nothing about where the backup files are. You know nothing where the files are, and you don't care. And Microsoft updates it constantly for you. You move up to IaaS, and PaaS is the cheapest way. You move up to IaaS, you're creating a VM in the cloud. You need to keep track of that VM. You need to allocate space for that VM. You need to patch that VM. You need to tell people not to call you. So IaaS, you have about the only thing it is, it's like you don't own the hardware. And that's good for some circumstances, but for SQL Server, guess what? IaaS costs more than PaaS. Managed instance is the most expensive of all. So you need to do more work, but you do get your SQL Server up into the cloud. So again, you don't have the hardware costs. Questions?
Does it support Power BI?
All of the three support Power BI. So we're currently using Power BI. Actually, here's an irony for you. We actually had to create a SQL instance in a VM in the cloud. So our only IaaS database, because the Power BI gateway to get to some of our on-prem data required a SQL instance in the cloud, and it had to be a VM instance. But yeah, all of these support Power BI. Including all of the previous ones that we were talking about too, Cosmos DB, the Azure Data Lake, all of those support Power BI. In fact, there is no true SSRS in the cloud other than Power BI or managed instance. Yeah, good question. So, any other questions on the various data options, kind of places to store your data in Azure? Okay, this next one I want to show you, and I got a couple of pictures of this too, so I can show you. How do you move data from place to place in the cloud? I mean, again, on-prem, it's pretty easy, right? You're moving it from here to there. And you SSIS, other different options like that. There really is no SSIS in the cloud, per se. And so you can build a VM and put your SQL server there, and you can put your SSIS there, and even your SSRS there. There's also Azure Data Factory v2. You want version 2, because version 1, it's like all text-based. v2 actually gives you a little bit of some graphical interface, and it is potent. And I'll show you in a minute how we're using this. This just came out, Azure Data Factory v2. I think it was February or March it went into preview, and I think it's live now. I hope so, because we're using it, because this thing is potent. so we just signed a new project, and we're receiving a file. You know, it's group health, it's their member file. So all the people that are part of those healthcare plans. So we get that file, and traditionally, you know, we take it up, we'd ETL it in, we'd take SSIS, pull it from the hard drive, transform it, and then put it into its final destination database, right? Azure Data Factory version 2, we're like, well, we don't have a lot of wiggle room on this time date, but let's see if we could use either Azure Data Factory or use SQL to pull that data in. And it's very similar to SSIS, but it's much more extensible. We're actually looking at now how we could hook it up to secure FTP, so the file can come right in, never even hits our e-commerce team, but it'll get loaded right up into Azure. There's an event grid that we set up, kind of like a file watcher. So all of a sudden the file hits there, and we're like, hey, here we are, kick off this pipeline, this Azure Data Factory pipeline. It says, okay, copy data, clean data, push data out, push data to our Azure Search, push data out to this flat file so we can send the errors back to the company that sent it to us. It's like, wow, is this cool? And we got it working. More than that, it's completely JSON based. So we defined our source file as a JSON document. We define our destination, the sink as they call it, in JSON. And then we create a mapping document saying column 1 goes to field 1. And we run that through, and boom, automatically deciphers the documents at the time, automatically does all our mapping. And if we ever need to change it, say they're adding a new field to the flat file, all we need to do is hit the 2 JSON documents and create. I guess we'd have to modify the table that we need too, but it's as simple as that. Just modify your table, modify the data in the document. SQL is another one that just came out. And this is more like, not Hadoop jobs, but it's kind of it's kind of like your MapReduce jobs in Hadoop. You can schedule it to go around and check out your data lake and begin the pre-aggregation process for you to use your analytics. I'm not running out of time yet. No, I still have like 25 minutes. I'm like, wait. Again, the Azure Data Lake Storage, Generation 2, the version 2. There's more things like Databricks. I'm not even sure I know precisely what Databricks are. I'm learning. Like I said, this stuff changes constantly. It's like, okay, what did it used to be and what is it now? But here, let me show you.
The Azure Data Factory, have you tried to use it to access like on-prem data, like on-prem SQL Server data? Is it?
So an Azure Data Factory to hit your on-prem SQL Server?
Yeah, like you're combining with like external files and stuff like that.
You could. I would bet that you could do that. For the files, the files would be pretty easy. You put them up in Azure, but you might need a gateway in order to hit your on-prem SQL Server, and that's probably how you would end up doing it. Let's see. As you look at the secret sauce. I wish I could say that I did this, but seeing how there's some people here that from one call, I probably should tell the truth. And yeah, this was Sarju and Luigi. I said, see if you could do it. And by golly, they went out and did it. I'm sitting in meetings and they get to play with all the cool stuff. So, but here it is. This is a copy data from our data store, Azure Blob. From there, we do a lookup. And really what we're doing is we're creating a file, say, hey, here's a new file that came in, so that when we push it, we're pushing all the data. And then our stored procedure task here, this is where we're going to clean the data. So we load it up into a load table, run a stored proc, which says, okay, is the numeric data numeric? Is the alpha characters, is it in the size range we're expecting? In some instances, like if it's a state, we do these kind of lookups. And that stored proc also splits it into a clean table and into an error table. And let's see if I can push this, hang on, over a little further. So this one here that I've highlighted, not too well, this is actually what copies our data up into the Azure Search. But all of this stuff is configurable, both at all this stuff. It's configurable. We set up parameters. Here's our name. Nothing really happening here. This is just the whole pipeline name. We start getting into a little bit of the really fun stuff in parameters. So we could start specifying where, so we can metadata drive all this. You can see here, okay, here's a text file. Really, we're going to replace that when the file gets dropped. Here's where we're looking for the new file to come in at. Here's our input source structure. So again, how does that flat file look? Again, if you notice here, hey, that looks a lot like JSON. Looks like that because it is. What's the import sync structure? Again, why they didn't call destination, I don't know. But again, all of that is defined in a JSON document, and we map it that way too. Really, really incredible. And what we've done too, and I say we and kind of the royal we, meaning that I'm taking credit for work other people did. But hey, We have all kinds of things. Oh, let me expand that first. And data transformation, general. Here's some of the different ideas that we can have. So we created this pipeline in such a generic way that all we need to do is define our different source and destinations, and we can reuse them every other time. So we're using the same pipeline to load a flat file that comes in into an ETL, but we're also using the same pipeline to move data from one of our Azure SQL databases into our ODS. So all it is a matter of is changing different connections, and then we have all these different types of paths. This, unfortunately, isn't really good at transformation. However, we could pull some SSIS transformation right into it using a different library. So there's a lot. This Azure Data Factory, this version 2, version 1, avoid. This version 2 is incredible.
Can you expand data lake methods?
Which one? Oh, sure. One thing, use SQL. All right, questions? All right, well.
How do you schedule that out?
You can schedule the Azure Data Factory in one of two ways. You can schedule it to run on a repetitive basis, or what we did with it is we had an event base. So we actually set up an event, so once the file drops into our drop directory, it automatically spins up the Azure Data Factory, passes the parameters in, and kicks it off. So completely hands-free. And by the way, all this stuff is completely deployable. There's, I forget the framework behind the scene, but it automatically builds right into CI development. We do all of our development in local and sandbox. Everything that gets deployed to every subsequent environment is by automated build. And even more than the automated build, we've recently started using Terraform to actually build out our Azure environments on the fly. And in fact, with this one, we're actually meeting with the infrastructure team this coming week in order to get it so that all we need to do to create a new Azure Data Factory is just to get it put it into Terraform so Terraform can do it. So when we go to create a new Azure SQL database, Terraform can do that. So there is a bunch of powerful stuff. And Control F5. All right. Okay, come on back where we were. Run onto that into security. Again, the base for all of this, and I'll kind of run through this, is all pretty basic stuff, but the base for all Azure is Azure Active Directory, which is extensible from both Azure and from your local on-prem AD accounts. We're also beginning to use Azure Key Vault, which allows us finally on the database side to have true asymmetric encryption. So in the past, we could only get the symmetric encryption, and then all the DBAs who had typically have privileged access can read all the privileged data. However, now we have a token on the development side as well as a token from the database side, and it's true asymmetric encryption using Azure Key Vault. There is an issue right now. We can't use symmetric keys on the database side because our symmetric keys rely on a certificate, A certificate relies on a file system. Hey, wait a minute, Microsoft. So that is something that the teams are working on. So hopefully, I'm surprised it's gone as long as it has. And then following that, data masking. So right now, a lot of our sensitive data, since we can't do a true symmetric key, we are using data masking, which stores the data unencrypted, but presents it encrypted based upon your access level. And behind the scenes, one of the really fun things about Azure SQL Database, TDE. Has anyone tried to enable TDE on a SQL Server level on-prem? It's not terribly difficult, but it's usually a pain in the butt. Azure, push a button, done. Really? Does it work? Yep. Trust but verify. It works. Pull it down and can't see the data. Restoring data. This is actually one of my fun stories. When I first started working with Azure SQL Database, it's like, well, where's my backup? Microsoft tells me, our Microsoft rep says, you don't need to know that, John. I was like, no, I'm pretty sure that the first time the database crashes and I need to go back to a backup, my boss is going to say, John, get that backup. And I'm going to have to say, oh no, Microsoft said I don't need to worry about that. Yeah. I like having a job. I like being employed. So you got to come up with a way to tell me, where's my backup? They're like, our Microsoft rep, no, you don't need to know. Backwards Bob, anyone know Backwards Bob? So he's telling me, nah, John, you don't need to know. All right, Bob, show me. And son of a gun, if he wasn't right, all you need to do is you go to your Azure SQL database, say restore. You say the date, the time, the millisecond you want it restored from. Anytime, any millisecond within the last 35 days. Boop, back. Huh? Yeah, it's that simple. What if you want more than 35 days? It's true, but it works. And unfortunately, I've had to go back and restore databases. And it comes back. And it's pretty incredible. TDE also works on your backpack. If you create not just a backup file, but a backpack, which is a database project, DACpack, plus all the data. And TDE encrypts it, say you can't take a prod copy or any other copy and bring it down locally and restore it and expect to see data. You can't even expect to open up the backpack because a lot of it's just text file and XML file. Can't even look at it there either. It's like, darn it, okay, you guys thought of it. Geo-replication. Literally, choose a place on the map, click boop, open your wallet, and it's replicated. Breaking it, just as easy. Just go in, say, stop replication. Done. Hey, done. A lot of cool things, but hey, why tell you when I could show you some of these things? And here we go. The part that never works the same way twice. Yes, what could possibly go wrong? Okay. So we're coming to our Azure Portal. Eventually, it looks like everyone else is on the wireless network too. So there's a whole bunch of things about your Azure instance. Don't worry, you're not missing a bunch of stuff. Here's how it's performing. So this is one of our instances of SQL Server, and look at that. In a graph, how well it's performed over time. Uh-oh, we got something going on there. Got to figure that one out, but I'm not at the office right now, so.
What's the duration?
Last hour? Yes. This is actually 3 p.m., so I mean, this is just a couple minutes ago.
Maybe that was your phone call.
Yeah. Oh, darn. Oh, I would never show prod. Uh-huh. So you can see here, this database isn't all that big, just about a gigabyte. But threat detection, what's this? Microsoft on the Azure database does an incredibly great job of saying, hey, someone who's never accessed this database before has accessed it. I get an email when someone does that, and I'm like, okay, who was this? And then it's up to me, or I'm trying to push this off to our prod support team to go back, figure out who's doing it. That's what this one is, almost certainly. Let's see if it'll. Come on. You're not going to do it for me? Ah, well. Let's look here then. TDE. Again, push button encryption. Automatic tuning. This is probably my favorite thing. What your automatic tuning does is Microsoft actually has your database log hooked up to machine learning algorithms. And what it does is it looks in and says, force plan. Okay, that enables you to just force this particular query plan. Not incredibly powerful, but it is. So say you have a new query plan that's performing poorly, you can actually go back to an earlier plan and say, use this one. Not too bad, but create index and drop index. What's this? Mega cool stuff. So your create index, so it does all this analytics in the background, and it says, hey, I think I can make this query perform a little better if I created an index here. And without it even telling me, it goes in and creates an index. And you probably think, oh, that's cool, and it hangs out there. Well, it hangs out there for a little bit as it still runs additional analytics behind the scene. Did this index actually make the queries run faster? And if it did, it says yes. And it includes that index in your database and keeps it there. If it says, nah, didn't help that much, it'll actually drop that index. It's like, really? What's drop index then? Well, it'll actually look through and see if you have indices that aren't being used. I've never seen it try to drop one of them, but where I have seen it try to drop is if we accidentally created a duplicate index and pushed it to production or any other environment. And I actually came across one the other day. It said, whoops, this IANA key index is duplicated. Huh, it drops it. First time I came across this, I'd put these plans on, or use the defaults, and it ran on through, and then all of a sudden I see, hey, it created an index. It was actually for the first time I was presenting on Azure SQL Data. It created an index, and then it said rejected by user. I'm like, wait a minute, I didn't go and reject this. I go, what's it telling me here? And then as I sat down and started to investigate, I was like, oh. I said earlier, we deploy everything through continuous builds. Well, when it threw that DAC pack, I have the database options set to, if it's not defined in my database project, drop it in a target database. So it looked, it didn't see the index it created for me, and it said, okay, bye. You don't like it? You don't have to have it. Son of a gun. I put that in my database project the next time. The drop index, the same thing. I still need to go back in and find that one that it just told me to drop the other day. But this, is it anything that a good prod developer wouldn't come up with? No, but you know what? I didn't need a person to do that. It's doing it behind the scenes, and I've got a lot of other things for a prod DBA to be doing. So it's handling a lot of this performance tuning automatically. And along with that, we get, well, we did performance overview. That was a jagged line. Oops. What this one is resource consuming queries or long running queries. It tells me the worst ones within my database. Really can't quite, can I get that all onto one? So this first one used 2.3% of our CPU. Hey, get rid of this. Delete previous version of Windows. Come on. Okay. So here it tells us our query ID, how much CPU it's utilized, execution counts, and the time it took. Now what we can do is we can actually drill into this query and find out all the things over time. How many executions it's run, how long it took. So I can see here 40 executions took 1 minute and 35 seconds to run. Oops. Since I have some of the developers here. Guess what? Recognize that? This is an EF query.
Yeah.
So these things are going to happen. So is it time?
I think you still have 15 minutes.
Oh, okay. Yeah, I still have 5 minutes, right? Okay. 4? Okay. So yeah, now I get the exact query that's taken all the time. Huh? I could gather all this stuff. I could say, okay, where is this? And we investigate, we fix it. And the thing is to catch it here in one of our lower level environments as opposed to letting this sucker get up to prod. But we have all these tools. And what I'm trying to do is I've been working with our production support team in order to find these long running queries and send me alerts on them. Because our databases, like I said, are still pretty small. I mean, in a gig, 2 gig time frame. So I told them, I go, if there's any query that takes more than 500 milliseconds to run, let me know, because that means something's wrong. I mean, if we only have 1 million rows in a database, I mean, nothing should be running in over half a second. So we do have that, and then like I said, there's a whole bunch of other information, so we could see how it's performed over time, and of which I have very little left. But there's such a plethora of information that you can get out here from Azure SQL database. And I guess I probably shouldn't run over, because that's typically what I always plan on doing. I plan on a 45-minute presentation, and I always run an hour plus. So I apologize for that. But some of the other things that are on here, and I just would like to call them really quick. The advanced threat protection. What this does is it actually proactively looks for like DDoS or anything massively hitting our database. And even like I said, unknown people hitting the database. Auditing, probably self-explanatory. The dynamic data masking, that's something I talked about earlier, how we're hiding some of it. Geo-replication, you can see here, we're looking at my secondary. Otherwise, it would tell us our primary. Automatic tuning, TDE. Questions? There are, I'll make sure to get the slide deck. I assume Pete's got a place for it up on the website. There are a couple things that Azure SQL database doesn't do too well, only because we're used to doing it on-prem. So I've got things like CDC and stuff like that, but there's ways to get around that. For example, CDC, we can use temporal tables to try to get some of those changes out. So there are a bunch of different things that, there are some SQL, I don't even want to say shortcomings, but ways that you have to learn how to do it in a different way. Believe me, all Azure is, and if you get nothing else from this presentation, just remember the Azure is changing all the time. And you may look at it now and then a week later it's like, huh, where'd that come from? And we've done it and it's like, okay, what can I do with it? So there's a lot of cool stuff coming. And I'll be around, so if you don't have questions now, you think of one later, feel free to hit me up. Thank you.